Hello, my name is Karthik Thumla. I'm the Principal Technical Marketing Engineer from the Palo Alto's IoT security team. In this particular video demonstration, I will go over the new industrial OT security demo, which provides a comprehensive zero trust security with zero operational downtime. So part of the demonstration, we'll go over the complete OT asset discovery using the new industrial OT security portal, followed by how we provide the complete compliance and reporting according to the NERC CIP and IEC 62443 guidelines, and the device visualization map according to Purdue levels, and the complete multi-factor risk assessment on this critical infrastructure and OT devices, followed by how we provide least privilege access policies as well as ML-powered policy recommendations with OT device context for policy enforcement. And finally, how we can protect the OT and ICS process integrity along with the continuous security inspection with OT threat prevention. So with that, let me go over the industrial OT security dashboard. So this security dashboard within the industrial OT security provides a complete visibility of the OT assets. Not just the visibility of the OT asset, it also provides the risk as well as the compliance data. So this particular dashboard is not just for network security administrators, though it says security dashboard, it is also useful for critical infrastructure specialists as well as OT plant managers. So the first thing when you come into the dashboard, you will see the inventory. So it provides a complete inventory view of your devices and how many of these devices have been monitored. Like you can see in this particular demo environment, there are like less than 2% of the endpoints which are being monitored. So now you can look into this to take the respective action by adding some additional coverage of the devices. And along with the inventory here, we also provide the total number of IoT devices and the subnets and the sites, like where you can logically group your firewalls and devices in their respective sites. So that's on the high-level inventory. And apart from this, it also provides the device distribution mainly based on the risk, like which type of devices are of high risk based on the category. Like here, the industrial category devices are of like high risk, which have like 5%, and similarly, office devices have like 100% risky. Like you can look into the device distribution based on risk so that the network security administrators can further go and patch these respective devices. So that's on the device distribution. And along with that, it provides a good overview of the subnets which are being used in the network based on the device types. The whole idea behind this is to provide an overview of subnets which are using mixed device types. Let's say you have both industrial and IT devices within the same subnet. You can identify those and you can further go and create segmentation policies from here. So this provides a good snapshot of this mixed device types. So apart from this device distribution, this dashboard also provides the complete risk overview of this tenant. So overall risk score and the main reasons for this particular risk score, which is being attributed to the number of alerts and vulnerabilities. And as a NetSec admin, you can go and you can take the respective actions by addressing the alerts and vulnerabilities directly from the dashboard. So in terms of alerts and vulnerabilities, it provides flexibility in terms of alerts distribution based on the severity level, based on the device category and the alert type. And very similarly, in terms of alerts, you can see in terms of vulnerabilities, it also provides flexibility in terms of severity as well as based on the vendor. Like you can pick like which vendor has most number of vulnerabilities so that you can further patch those particular devices. So that's on the risks. And apart from risk, the other set of capability it also provides is the overall compliance based on the data, like devices which are running internet connections, devices with weak credentials, unsecured protocols, and unsupported operating systems, which you can see over here. So you can click on any of these devices and you can send this information to the threat investigation team or security administration team for further patching. So this is the high-level overview of the dashboard. So it also has the complete the device inventory. So here I have selected the industrial device category. So you can click any of these device types, and you can also pick the respective time frame. You can start all the way from 1 hour to 1 year. So you can filter based on the time frame. So using our machine learning model along with our patented App ID technology, which provides deep packet inspection and protocol decoding. With the crowdsourced telemetry data, we provide the accurate classification of all these critical infrastructure or OT devices. So in this example here, you can see we provide more of like a three-tier classification. So the first one is the category view, where you can see the controllers, HMI devices, automation devices, sensors, and things like that. So this is the first level of classification. So why category view is important is it provides more granular segmentation view, because at the category level, you can go and you can write your segmentation policies and you can group those devices together. Because oftentimes you can see HMI within the Purdue level, they are in level 2. They have access to respective applications irrespective of what vendor it is. So you can go and look into the category level to provide those granular segmentation policies. And within that category, we provide the second level of classification, which is based on the vendor make and model. Like here, I have Rockwell, I have Siemens, I have Atlas. Like every specific vendor make and model will have their own respective CVEs based on end of life OS, based on the characteristics of the particular model. So we can identify these vulnerabilities based on these profiles. Like here I have Rockwell, Omron, and Siemens is within this industrial category. And within that profile, we have further classification based on the unique context or the unique personality of the device. Like here, I have Rockwell Automation PLCs, there are 11 devices. Like these 11 devices are unique. Every device might have some behavior anomalies. A device might be running some malware. A device might have access to the internet. So we can clearly identify the behavior anomalies, threats, and malwares which are associated with this unique context of these devices. So that's the three-level classification, and that's a clear differentiation when you compare Palo Alto's industrial OT security solution versus any other vendor, because we use machine learning to provide this three-level classification. Whereas most of the vendors out there in the market, they use static signature-based approach to provide device classification. So that's on the visibility side. And the other set of capability, what we also provide is the ability to plot the devices based on the Purdue level mapping. So you can see here have different set of devices within the Purdue levels, because oftentimes the industrial devices are categorized within the Purdue level, all the way from level 0 to level 3 based on the processes. Like here, we can easily plot those devices into these Purdue levels, and you can create these advanced visualization maps based on the time range. And also you can further fine tune these visualization map not just at the Purdue level, you can also do that at the subnet level, at the category level, at the profile level. And you can view those devices. Like the whole idea behind this is not only provides the visualization map, but also helps in creating more effective segmentation policies and also removes unwanted communication. Like here you can see the moment I click on this particular map, I can clearly identify the category of devices within these Purdue levels, because I have selected category of as my second level of classification. And within that, you can see some kind of connections which are happening between these categories within the Purdue levels. Like this control systems engineering workstation is talking to industrial automation devices, and it is using these app IDs like SIP IP, which is typically used by Rockwell automation devices, right? So you can see all that communication which is happening. And you can further dive into a specific set of communication to further look into the details. Like here between HMI panel and control systems engineering workstation, there are some devices which are talking to the internet. There are some devices which are of like high risk or critical risk. So you can further dive into the details of those devices. So if I double click onto this control systems engineering workstation, you can also look into the set of communication which is happening on these devices across different set of categories or different set of individual profiles. Like here, how control systems engineering workstation is talking to the IoT gateways, industrial controllers, HMI panels, as well as internet addresses. So you can also additionally double click and look into what those internet addresses are and what those HMI panel devices are. So overall, if you look at it, it provides a more granular view of how these industrial devices are communicating across the Purdue level. And also, if there are any critical or high-risk devices, we can automatically flag them within the Purdue levels as well. So that's on the visualization map. And in terms of the device inventory, we can provide more of like a top-down view based on the risk posture of these critical infrastructure devices. And when I say top-down view, you can see the overall risk score, which is 100, and you can see the device contextual data like the profile, the vendor, the model, the operating system, the VLAN ID, and along with that, there are 80 different attributes which we gather by passively monitoring the network traffic, or in some cases, it could be from third-party integrations like the asset management tools, network management tools, or vulnerability scanners and things like that, where we can additionally glean some attributes. So the beauty of these additional attributes is we can use any of these to identify the devices based on their risk posture, based on their compliance status, based on their identity details, right? So that mainly helps in the compliance assessment functionality according to the NERC, SIP, as well as the IEC 62443 guidelines. We can help in providing these OT tenants always to be audit ready. So you can use any of these to filter. Like here, I want to select in the industrial controller categories, and I want to identify the devices which are running unsupported operating systems, or maybe devices which are of like high risk. I can click on risk over here, and I can select the risk as like critical or high, and I can click on search, and you can automatically see the devices. Like here, I have a Siemens PLC and Rockwell PLC devices. And similarly, if you want to select a device which is running unsupported operating system, so you can select the OS version, maybe like any device which is running like Windows 7, you want to search those devices which are running like unsupported operating systems, and you can clearly see the devices if they are running. Like here, I have selected industrial controllers. If I want to select a more broader level, let's say device type, as industrial, and I want to select all the devices which are running Windows 7, you can see there is an engineering workstation, which is a control systems engineering workstation, and it is using this particular operational VLAN, and it is using an unsupported operating system, which is Windows 7. So overall, you can use the compliance assessment functionality mainly to identify these devices, and you can always be audit ready. So let's go back and go to the inventory tab again to see the individual devices based on the risk score. Like here, you can see I have these set of devices which are of like high risk. Hence, these devices are shown on the top. Like here, I have a Siemens HMI device. Let's dive into the details of the Siemens HMI device to see the set of identity and risk data we provide within the industrial OT security portal. So the first thing what we show here is the identity information, like the overall category, the profile, the vendor, the model, the OS group, firmware version, and all. And apart from that, we also provide the switch port, switch IP, and switch name. So this is something we glean from the SNMP crawling or through switch infrastructure integration. And you can also see the Purdue level, like which level this particular HMI device is. Obviously, the HMIs are in the level 2 within the Purdue level. Like we can also provide the overall confidence level and confidence score. So higher the confidence score, that accurate we are in terms of device classification. And also we provide policy recommendation for the devices which are of like high confidence score, right? So that's on the identity side. So you have all the flexibility in terms of editing the device. If you want to modify a specific set of information, you can go over here and you can modify any of this, or you can, if you want to do it in bulk, you can select a bunch of devices and you can do the editing, and you can train the ML model as well. So that's on the identity side. And apart from identity, the other set of capability, what we provide is a multi-factor risk assessment. So what industrial OT security takes into consideration is the static behaviors, the weak postures, the behavior anomalies, and along with that, we also get the threat feed from the firewall log, mainly to identify any zero-day threats, anomalies, and all. We take all this data into consideration to provide more of like a baseline model. And if there is any deviation from its baseline model, we elevate the risk score. And here the risk score of this particular device is 100 because this device has some alerts and vulnerabilities within the software category and the internet category. And you can further dive into the details to see why this particular device has the risk score of 100. So if I go into the risks tab in here, you can see there is a suspicious port scan activity which happened on this particular device. So we provide some additional insights on like where this particular port scan happened. And also in terms of scanning, like we show when this particular scan happened and what is the last time this particular scan happened. And as a network security administrator, we provide all the flexibility in taking the respective actions on these alerts and vulnerabilities by like sending that information to a ticketing system like ServiceNow or AIMS, or you want to send that to a SOC tool or SIM, you can send that over to the SIM. If you want to assign that part of a change management, you can assign that to your respective user groups. If you want to take more of like a action by resolving the alert, you can go and you can say that no action is needed. If you think that that's a normal behavior, you have some kind of a vulnerability scanner within the network, you can say that this is a trusted remote destination so that this particular alert doesn't get resurfaced again. So we provide a lot of flexibility in terms of mitigating the alerts, understanding the threats, as well as eliminating the threats within the network. Like that is on the alerts. And similarly, you can see we can also look into the abnormal behaviors. Let's say if someone issued some incorrect command on this particular HMI device, looks like there is a backnet command. Based on the behavior anomalies, we can easily identify those and we provide the recommendation. And also we look into the weak postures of the device, like if the device is using the default shipped credentials, we provide those credential information over here, and we also show like when it is first and last detected. So that's primarily on the alerts. We also provide the CVEs or vulnerabilities which are associated for these critical infrastructure or OT devices. Like here you can see there are some CVEs which are affecting this specific model, which is the Siemens HMI, which is this KPT 700 basic. So from the industrial OT security standpoint, we provide what is the impact of that particular CVE and what is the recommendation we provide. And in terms of alerts and vulnerabilities, we can also adjust based on their risk score. Like here, if you think that that particular CVE has low impact, you can go and you can reduce the severity. If you think that it has a high impact, you can go and you can increase the CVE. So we provide the flexibility in adjusting the risk score of this particular CVEs. So overall, this provides more of like a multi-factor risk assessment by taking into consideration the static behaviors of the device, the behavior anomalies, can look at the command levels, as well as it learns the CVEs and threat intel from the firewall. And the other set of capabilities, which is tailor-made for these critical infrastructure devices, is our ability to identify at the command level. So what we provide is the more of like OT and ICS process integrity. So we can protect the OT and ICS process integrity by looking into the app level, by looking into the command level, or at the integer level to see if there are any anomalies. Like here, I have this Rockwell PLC device. So if someone is issuing a PLC stop, right, which is the SIP IP application, which is being used by the PLC. And if it is coming from a HMI panel, or if you can pick based on the subnet, if you want to, you can also pick it based on the switch name or IP address. So you can create these advanced alerts based on not just at the application usage, but also at the traffic volume. And you can generate this high risk or critical risky alerts. And if you want, you can also do restricted network access for these set of devices, which are of like high risk or critical risk. So overall, if you look at it, it can go and read at the command level, at the integer level to identify these behavior anomalies. So because if someone issues PLC stop, that can bring down that plant, so that will have an adverse impact on that particular network. So we can look into these commands, have the intelligence to look into these commands and the app IDs to identify if there are any behavior anomalies. So that's the rules engine capability, mainly to protect the ICS and OT process integrity. So once we provide the visibility as well as the risk framework, the next step is to understand the set of applications this device is talking to, so that you can go and you can create your least privilege access policies, or where you can go and you create more granular segmentation policies based on the OT device context. So that's where the OT industry security portal provides the unique value prop, where it can clearly identify the set of applications or the app IDs this device is communicating with, as well as the destinations or domains it's talking to. Like here, this is a Siemens HMI device, part of the network usage statistics. It can clearly identify the intranet applications, internet applications, or device talking over various VLANs. It can automatically plot them and also shows what those domains are and what those destinations are and the applications which are being used to communicate with. And here, the Siemens HMI is talking to a control systems engineering workstation. It is talking to a PLC device. It is talking to a Microsoft mainly. I believe it's for the firmware updates and things like that. So you can see these are all the different set of domains or destinations this device is communicating with. So now that you have this particular data, you can go and you can create more effective segmentation policies. So how we do that is, let's go and select that HMI device. So this is a Siemens HMI, which we have seen earlier. So we provide the overall behaviors for the Siemens HMI device. So both for outbound as well as inbound. So outbound is where we typically see these devices talking to various destinations. So we typically create these least privilege access policies for outbound destinations. So when we write these least privilege access policies, we actually take into the consideration of the applications which are unique to your environment. And along with that, we also get the intel of the crowdsourced telemetry data. So based on that, we can clearly identify the common applications which are being used by the Siemens HMI panel. So we take into the common applications of the Siemens HMI panel, and along with that, we map them into the unique applications so that we have a clear understanding of the app IDs which are being used by the Siemens HMI panel. So now you can select all that and you can select next. And here you can even create your security profiles like your spyware rules, malware rules, mainly to do native threat prevention. And also you can do URL filtering and all. You can apply these. If you want to customize your source and destination zones, you can go and you can customize the source and destination zones. You can select next and click on create and activate it. So the moment you activate it, what will happen is this policy gets pushed into the Panorama, or if you are managing this policy directly on the NG firewall, the policy gets provisioned onto the NG firewall as a policy recommendation. So from the industrial OT security portal, we are recommending policies which are ML powered. So part of our machine learning model, we can clearly identify the app IDs which are being used, and we are taking those app IDs and we are sending that information to the firewall. Now, on the firewall, you see this as a policy recommendation. So now as a firewall admin, if you think that that's a relevant policy you want to enforce, you can enforce the policy by importing into the policy section. So all you need to do is click on here, import, select the rules. I want to select right next to the Siemens PLC and hit OK. So once you do that, it gets pushed into the policy section. If I search for the HMI here, like here you can see this is a Siemens HMI policy. And the beauty of this is it is tied to the OT device context, which is a Siemens HMI panel. And that's a device ID we are using for the policy enforcement. So every time when there is a new HMI panel comes onto the network, automatically it will go and hit this particular rule and only allows access to these app IDs, which we have seen on the industrial OT security portal. And along with that, within the same policy, you can see we have created the security profiles mainly to mitigate threats, malwares, as well as we have URL filtering policies and all within the same profile. So within a single policy rule, you can not only do the least privilege access policies and do policy enforcement, you can also do threat prevention. And apart from that, if at all you want to do some kind of role-based access control using user ID, let's say you have a HMI, mainly a Siemens vendor who wants to access this HMI device, so they can go and they can create this user ID based policies to allow access to that particular contractor or that particular vendor to access this HMI panel for remote operations, allowing access to certain app IDs. So we can even provide that level of segmentation using the RBAC capabilities of the user IDs, right? So overall, if you look at the demo, we have provided the complete OT asset discovery, followed by the compliance reporting according to the NERC, SIP, and IEC 62443 guidelines, so that the industrial OT environment is always audit ready. And also we provided the Purdue level visualization map with the complete multi-factor risk assessment by looking into the various risk factors and CVEs, which we learned from the vendors. And by looking into the behaviors, we provide ML-powered policy recommendations with least privilege access policies, and we enforce the policies using the OT device context on the NG firewall. And also, we have protected the OT and ICS process integrity by looking at the command level and the application level, as well as we did native threat prevention on these OT and ICS devices. So using our unified NG firewall as a platform, we can provide the complete discovery, we can do risk assessment, we can provide least privilege access policies and native threat prevention. So I hope this video is useful, and thank you everyone for watching.